a right triangle. So we're going to start this whole thing called right triangle trig, which is, hopefully you learned a little bit about it last year, but last year was a blur. Or geometry last semester was a blur. But if you had a right triangle, okay, so what I'm going to show in the next 3 minutes is really the most important part of right triangle trig. Why is the most important part? Because we've got to figure out what those names, if you look up on the board and see in blue, see that sine, op, hype, adjace, hype, op, adjace, all that is right triangle trig. So what we got to do is figure out what are those words. So we all know in a right triangle that the hypotenuse is always going to be the longest side, opposite the 90, okay? Thumbs up on that, right? Everybody agree with that? So if we've got that. Now you really have three angles, but we don't use the 90. Don't use the 90, but we have two other angles. And so I'm going to use this symbol theta, okay? Theta is just a symbol for an angle, okay? That is just, it's called theta. It's a Greek letter, but for us, it just means angle, okay? So when you see that symbol, it means angle for you, okay? Now, pretend, just use your imagination. Just pretend that this was a lake. It was a triangular lake, and you're standing right here, and I say, okay, Olin, throw a rock to the opposite side. That'd be the opposite side, right? You ever agree? That's the opposite side. So this would be my opposite side. So that side has a name. This side has a name, the hypotenuse, and this side right here is right next to you. If you're standing here throwing the rock over the side, so it's adjacent to you. Are we okay on that? Right? So you throw the rock to the opposite side. This side already has a name called the hypotenuse, and this side has the adjacent. But let's say Olin then walks to the other side and walks all the way over here. So then he walks to the other side, and he's standing here. Then the names of the sides change, don't they? Because he can throw the rock to the opposite side here. And then the hypotenuse is still a hypotenuse because it's always 190. But now this is the side next to you called the adjacent, okay? So everything depends on the angle. Everything depends on the angle and where you're standing. Okay, so let me go ahead and move this aside. And let's write down some of these things. Define the 6 following trig ratios. So what I want to do is go back and I'm going to draw a right triangle. Okay, and we're going to choose one of these two angles. That's not a very good right angle. That doesn't look very right. Use your imagination. It's a right angle now. So let's put Olin here, theta, okay? He could be either here or here. Doesn't matter where he's at, but right now let's put Olin here. So the angle theta, the angle, it's my angle symbol. I'm going to call it theta because that's the Greek letter theta, but for us it means angle, okay? So if that's the case, then this would be my opposite side because I throw the rock to the opposite side. This is my hypotenuse because the hypotenuse is always the longest side or the side opposite the 90, and this side's the adjacent side, okay? I know if you were to stand over here, then that'd be the opposite, right? If you were standing here, that'd be the opposite. That'd be the adjacent. Okay, now, sine of an angle. So we're going to, is always sine of some angle is always equal to the opposite side over the hypotenuse. So there is a relationship. If the angle gets smaller, then the opposite side gets smaller and the hypotenuse gets smaller, right? So between all three of these, when one thing changes, it changes the other two. Everything of those ratios are in our calculator, okay? And that's why in our calculator we get these sine, cosine, and tangent. So inside of our calculator are all those changes between the three things. Now the cosine of some angle, we'll say theta now because that's theta, is equal to the adjacent side over my hypotenuse. So same thing. Here's my adjacent side, here's my angle, and here's my hypotenuse. If one of these things changes, like if the angle gets bigger, then the hypotenuse has got to get bigger, or the adjacent, but there's a relationship between the angle, this side, and this side. And all of those relationships are in our calculator under this cost button, okay? So the tangent of theta is equal to the ratio of the opposite side, thank you, over the adjacent side. So you can imagine, same thing on this triangle here, if the opposite changes, the angle changes, or if the adjacent changes, then it affects the opposite and the theta. So all three of these are connected, the angle, the adjacent side, and the opposite side, and all of those different ratios are inside our calculator under tangent. So we hit our tangent button, it's got all of those different ratios in, okay? Because it could be any angle, right? So there's no way we can memorize all of these different ratios, but we can. The calculator has it. Now the cosecant, and I did not invent this, I just teach this. The cosecant, you think the cosecant goes with the cosine? No, it does not. Cosecant goes with sine. Cosecant does not go with cosine, does not. And I cannot tell you why. So the cosecant is just the inverse, it's just the inverse of sine. So it's going to be the hypotenuse over the opposite. It's not used very much, okay? It's not used very much at all. The secant goes with the cosine. And again, I know it doesn't make any sense. You think cosecant goes with cosine, but it doesn't. Secant, though, goes with cosine. And so it's the inverse of my cosine. So therefore, we've got secant is going to be my hypotenuse over my adjacent. Okay. Now the cotangent makes sense. It goes with cotangent. Cotangent goes with tangent. That actually makes a lot of sense. These two go together. And again, it's going to be the inverse. It's going to be the inverse of tangent. So instead of the opposite of the adjacent, it's just going to be the adjacent over the opposite, okay? So what I have up here makes it really easy. I mean, this is up here, it's always up here because it's something we use all the time. There it is, the sine, opposite of hypotenuse, cosine, adjacent of hypotenuse, tangent, and then the inverses are just the flip. Cosecant, secant, flip it right, cotangent. Pretty easy? Okay. Now, this stuff is actually used everywhere. It is the most used mathematics. You don't know that yet, but I'm going to show you, okay? So let's take a look at this. Find all 6 ratios of angle B. So angle B, right? So everything starts with the angle. Everything. You always have to go to the angle first. So think of this. Well, we're going to pick on Olin again today. So Olin's standing right here. He's standing at angle B. Theta, okay? Therefore, if Olin's standing here, the 4 is my opposite. You guys agree with that? The 3 is my adjacent, and the 5 is my hypotenuse. So I'm going to write that down. Here's my opposite. If you'd be at angle A, it'd be a different opposite. Angle B, that's my opposite, that's my adjacent, and that's my hypotenuse. So we want all 6 trig ratios. So let's start with sine of B. Okay, sine of B. And if we look up on the board or we look in our notes, we know that sine is the opposite of hypotenuse. So it's just 4 over 5. That's just all we want. Because we want all 6 ratios. So when you say ratios, I'm looking for the fractions. Ratio is just a fancy word for fraction. So that's my answer. Cosine of B, well, cosine, if we look up on the board or look at our notes, cosine is the adjacent for the hypotenuse, so it's just 3 over 5. The tangent of B, if we look up on the board or in our notes, the tangent of B is equal to the opposite over the adjacent. Opposite over adjacent is the 4 over 3. And now the next 3 are easy because it's just the reciprocal. It's just going to be the inverse. So cosecant, that's the symbol, cosecant of B is 5 over 4. I just flipped the fraction. That's all I did. That's all you do. It's easy. The secant of b, again, is just going to be the reciprocal, which is going to be 5 over 3. And the cotangent, which again is just the reciprocal of tangent, is going to be 3 over 4. Okay, those are the answers. Now, what do you do with that? Well, let's do one more example, and then I'm going to show you what you do with it, okay? Thumbs up on that, pretty easy? Yeah. So I'll wait for you, and I'll turn the page. And I'm not going to do all of the problems on this back page. I want to show something else, okay? Abby, you got it? So let's do example 2. And we don't need to do 3 or 4, okay? So example 2 says sine of theta equals 5 over 13. Well, all right. What I probably need to do is I want to draw a right triangle. Okay, so I'm going to draw a right triangle, and that's going to help me out, okay? So I'm going to draw a right triangle. So draw a right triangle, okay? And let's put theta in a right triangle. I know that this is my hypotenuse. This side would be my opposite. And this side is my adjacent side. How am I doing? Okay. Now, what I know about sine of any angle is equal to the opposite over the hypotenuse. And that's our ratio that we just learned. And it's up on the board for us to see, right? So in this triangle, the opposite is 5. Okay? Yeah, Ellie?
How do you know that's not related?
How do...
The other angle?
We could have put it up there. Yeah. You want? Don't change anything. Yeah. You could have put it here. Totally right. Yes. Absolutely. And then it's not going to change anything here, except for it will just change the way our triangle looks, but it won't change all the answers. Really good question, because if it's here, then that's the opposite. Which I'm going to put the 5 there, but in this case, I'll put the 5 here. Why would I put the 5 here? Because of that, right? And I'll put the 13 here. You put theta here, put the 5 there, okay? Good question. It won't change our answer at all. I just drew the triangle, right? We're going to find, Ellie, we're going to specifically find out exactly what these triangles look like later, okay? Because that's a really good question. I mean, I just drew a triangle, right? What we want to do tomorrow is figure out exactly what these triangles actually look like, okay? So now, my hypotenuse, my opposite is 5. So I'm going to put a 5 right here. Because the opposite side has to be 5. I'm going to put a 13 here. Okay? What I don't know is the adjacent side, but you guys know Pythagorean's theorem, don't you? Right? Everybody knows Pythagorean's theorem? So to find the other side, I'm going to go a squared plus b squared equals c squared. So I'll go a squared plus 5 squared equals 13 squared. Okay? I mean, you guys learned this in middle school, right? And this is easy, okay? So I just have to find for my adjacent side, so a, b, c. So I'm going to go a squared plus 25 equals 169. I'm going to minus 25 minus 25. I'm going to get a squared equals 144. Square root, right? And so then the other side is going to be 12. Okay, so let me put 12 here, okay? How am I doing? Everybody good? Now we're just going to do what we did over here because we have our triangle, right? So we know what the sine is. We know the sine is 5 over 13. I know that because it was given to me, right? But now we need the other 5. So the cosine of theta, Well, cosine's the adjacent over the hypotenuse. I want you guys to get used to looking up on the board because it's just right there. So the cosine's the adjacent hypotenuse, which is going to be my 12 over 13. I know my tangent of my angle. Tangent is going to be my opposite of my adjacent, right? We can see that. So opposite over my adjacent, which is my 5 over 12. My cosecant of theta, which is the reciprocal of sine, okay, is going to be just the reciprocal, which is going to be a 13 over 5. That's pretty easy, right? My secant of theta, which is going to be the reciprocal of cosine, is just going to be a 13 over 12. And finally, I'll put in my cotangent of theta, which is going to be the reciprocal tangent, which is just 12 over 5, okay? All right, now, I want to show you how it's used, okay? So that's why I cross this off, okay? So draw this right triangle, okay? So what's the big deal? Why right triangle trig? What is the big deal, okay? Let me give you an example. If I know that this angle is, let's say it's 30 degrees, okay? And I know that this side is 10 centimeters. I could find this opposite side, okay? So let's find the value of x, which should be this side right here, the length of this side. So, I mean, you can think of all the applications, the height of a building, right? How high a rocket goes, I don't know, how tall a tree is, all tons upon tons. You're building a roof, right? And you need materials. How tall is the building, right? Tons of applications. So what do? We do it this way, watch. So go to the angle. Always start with the angle. Always, 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 always start with angle. Okay? Now, from the angle, what is the name? Now, I want opposite, hypotenuse, adjacent. What is the name of this opposite side? What's the name of the side I just told you? What's the name of this side? It's the opposite, right? What's the name of this side? Adjacent. Everybody agree with that? We don't know the hypotenuse. We don't care in this problem. We don't care. So if we have our angle and we want to find the opposite, we know the adjacent, we go opposite, adjacent. Those are the two things. We look up on the board and we know we have to use tangent, okay? We want to find the opposite, we know the adjacent. Opposite, adjacent, we look up on the board, we know it's got to be tangent. We're going to set up tangent of theta is equal to my opposite over my adjacent, okay? So I go to the angle and I look for the two sides that I'm working with. I find the correct ratio I get. Okay, so now let's put, this is really tangent. Theta means angle, right? And that's 30. My opposite is x, and my adjacent is 10. Okay, so let's fill in what I have. Now it's easy. I'm going to multiply up 10. If I multiply both sides by 10, I'll rewrite this as 10 times the tangent of 30 is the value of x. Now your calculator, okay, and your phones will do these. We gotta be careful though. My pre-calc kid's been using. So if you go into your mode and it says we want to be in degree mode, got to be in degree mode, okay. You got to be in degree mode. So hit mode. My pre-calc kids have been doing things with radians, and if I just go 10 times the tangent of 30, I get an answer, 5.77, and that's the length of that side. Okay, that's all I have. Homework's pretty short. I have for homework, and you guys, if you didn't get this answer, I'll help you. Let me put this down. Page 225. We'll do problems 1, 2. We'll do problems 5 and 6. And the extra is number 3, okay? And that's all I have. Let me stop recording so I can find my button. Here it is. Stop. Stop. Okay, use this button. Let's see if this one works. Stop.